Then quickly note down karo questions. Arrange the reactivity order. Okay, quick note down. COCS3. Okay. Quick. These are the 4 questions. What arrange karibo na reactivity of these haloalkane or haloarine. Take some time. A question note karo. Then I will discuss. तुम्हें आंसर लिखो तापरे हमें डिस्कस करें. Then try करचो. Quick. If you have any difficulty, write in the chat box. Take 2 more minutes, then we'll discuss. I hope all of you are doing. Now try to recall what is the order of reactivity of haloalkane haloarine and which is the site for which is the reactive site in haloalkane and haloarine. Okay, which is the reactive site in haloalkane haloarine? Then discuss quick. Last 2 minutes. Okay. Now, student, if you'll see which side is the reactive side. Okay. Reactive side in haloalkane, the reactive site is carbon halogen bond. Okay. In haloalkane or haloarine, the reactive site is carbon halogen bond. So when the bond is supposed to be dissociated, তাহলে কোন হবো না আমি দেখি যে haloalkane রে halogen is more electronegative, so it carries partial negative charge and carbon carries partial positive charge. Okay, carbon carries partial positive charge and halogen carries partial negative charge. If the bond dissociate হবো, carbon will be converted to carbocation and halide ion is released. তাহলে এটা কই পারিবা more the reactivity of or more the stability of carbocation, more the stability of carbocation, more is the reactivity of haloalkane or haloarine. So this is the concept. More is the reactivity of haloalkane or haloarine. Now we can see this first case. First case the answer is this. The answer is this. Now first that is tertiary carbocation, then secondary carbocation, then primary carbocation, then methyl carbocation. This is the answer. Second যদি দেখিব, this is most stable, then second, then third. আগে answer লিখে দিয়েছি, then we will discuss. One, decreasing order, right? First, you compare with your one answer, जो answer तो मिली थी, then we'll discuss it again. Just take 1 minute. तुम answer से compare करो. Compare कला परे, तापर हम discuss करेंगे. Take some time and analyze. तमें जो answer मिली थी answer मिली थी एठी जो answer जैसे कहाँ different अच्छी एक गोटे मिनट पे analyze करो. Then we'll discuss. ओके एनालाइज करो सेकंड क्वेश्चन देखो जदि सेकंड क्वेश्चन देखियो जो आंसर देछि कार्बोकैटायन बनिबो this is the carbocation so this is known as allyl carbocation it is stabilized by resonance तामाने ये कार्बोकेटायन इजीली बनी परिबो then next देखियो here this is vinyl chloride in vinyl chloride carbon halogen has partial double bond तो कार्बन हाइड्रोजन has partial double bond तो ता रिलीज होगा डिफिकल्ट हो बुझ पल्लो क्विकली नोट कर दियो स्टूडेंट क्विकली नोट डाउन ओके ताल देखो एटी आंसर allyl is most stable तापर एटा आसीबो आ vinyl थोड़ा least stable होगा as it has partial double bond character क्वेश्चन नंबर सी जे देखिबो ताल देखो क्वेश्चन नंबर सी रे फर्स्ट chlorine and carbon has partial double bond character second kono now that is आपको कहि परिबा क्लोरोबेंजीन okay this is benzyl chloride after release of the chlorine as the chloride ion the carbocation बनियो benzyl carbocation that is stabilized by resonance अब एठी जे देखिबा ए जो कार्बोकेटन बनिबो it has four hyper conjugate hydrogen अब एठी जो कार्बोकेटन बनिबो it has two hyper conjugate hydrogen ताले now the answer is clear four hyper conjugate hydrogen and two hyper conjugate hydrogen so of course four hyper conjugate hydrogen is most stable okay अच्छा जदि लास्ट क्वेश्चन देखिबा सबुते तो बेंजाइल क्लोराइड अछि डिफरेंस कहा में हबो आ डिफरेंस जदि हबो that will be due to the presence of the substituent which is present the substituent एटी कोड अछि para position रे so what is the nature of cs3 that is plus I or it contains three hyperconjugate hydrogen OCS3 that is plus R COCS3 that is minus R now you can compare your answer एबे तुम निजे कंपेयर कर परिबो सबठो मोस्ट स्टेबल के हबो ना प्लस आर हबो प्लस आर स्टेबलाइजेस द कार्बोकेटायन मोर देन प्लस I then no effect then minus r decreases the stability of carbocation minus r again repeating minus r decreases the stability of carbocation I think it is clear should quickly note कर दियो निजे एक्सप्लेन टिके कर दियो जो वर्ड रे आंसर and if any difficulty up to this write in the chat box student then student पचार कौन लिखियो तो क्वेश्चन देखली से क्वेश्चन ଆଉ जतर आंसर एक्सप्लेन कली से आंसर एक्सप्लेनेशन हम निज रेफरेंस पे नोट करते ओके नेक्स्ट नेक्स्ट हम देखिबा this is the reactivity now write down some questions for conversion some questions related to haloalkane and halogen These three questions, quick. And one more question. Yes. Take some time. Then quick, huh? Jaldi. Then John, complete color, write in the chat box. Then John, complete color, student, write in the chat box. All the conversions are related to this chapter only. Okay. Last 2 minutes. Okay. Now we are going to discuss in haloalkane. We can convert the haloalkane. We can prepare the haloalkane from alkane directly. Okay. ताले हमें alkane रू केवल haloalkane ही convert करी परिबा. We cannot convert the alkane into any other compound directly. तार reason बुझ परलो. काहे कि ना हमें कहले haloalkane हमें alkane रू बनै परिबा. तादर फिर कौन अछि ना two reactions are mainly there. One is chlorination, another is bromination. So between chlorination and bromination, the difference कौन अछि? Now chlorination is more reactive. It forms the mixture of products, whereas bromination is less reactive and more selective. It forms the major product, basically at the tertiary or at the secondary. ठीक? अच्छा. ताले मते propane देछि. Propane रू हमें only ब्रोमो 2 ब्रोमो प्रोपेन बने परिया. त रीजन कोन अदे क्लोरिनेशन करिबा प्रोपेन रो हमको मिलिबो 1 क्लोरोप्रोपेन and 2 क्लोरोप्रोपेन. So this bromination H nu 2 bromo, but our desired product कोन अछि 1 bromo. So terminal position by हमें गोटे रिएक्शन जानते, that is anti Markovnikov rule. Anti Markovnikov rule by reactant कोन दरकार अछि, रिएक्टेंट दरकार अछि alkene दरकार अछि. एठी हमें एलिमिनेशन करिबा alcoholic KOH this. तापर हमें hydrogen bromide in the presence of peroxide. So this is the product. Quickly note कर दियो जो नोट करना थिलो. Okay, note कर लो. Now second देखो देखिए that is 2 methyl propane. तो 2 methyl propane रो हमें बनेबा 1 iodo the compound. So this एठी भी हमें only bromination ही कर परिबा. So tertiary product will be major product. तापर हमें यूज करिबा alcoholic KOH. This is the product. हम दरकार कोन अछि आयोडीन. हमें यदि HI ऐड करिबा HI ऐड करले एट कोन बनिबो at the tertiary position iodine will be attached. काहे कि ना that will form the Markovnikov product. But हमर एट कोन दरकार अछि terminal position iodine दरकार अछि. ताले केस रे हमें hydrogen bromide in the presence of peroxide this. तापरे sodium iodide in acetone, Finkelstein reaction, halogen exchange. Is it clear? Note down, friends. Friends, note color. Next, third question. Third question देखो. Okay. Again, एठी हमें only bromination ही करी परिबा. Okay, bromination. तापरे जदि हम एठी अल्कोहल के होची यूज करते स्टूडेंट. अल्कोहल बनिबो 2 ब्यूटेन. बट हमर टर्मिनल पोजीशन दरकार अछि हमको 1 ब्यूटेन दरकार. So 1 ब्यूटेन पई हमें को रिएक्शन नबा. को रिएजेंट नबा ना that is Hoffman product. So tertiary butoxide. Then when tertiary butoxide number, then we will get 1 butane. So then alcoholic acid, then the product would be 2 butane. एठी हमें add कौन करिबा? Again anti-Markovnikov. Okay, note कर दियो. Next, तापर जो fourth question. Any doubt up to this? Write in the chat box. Okay, no. So the next one, benzene to benzyl bromide. So benzene ru ame toluene बनै परिबा. How? That is by following Friedel-Crafts alkylates. Toluene को हमें either NBS यूज करिबा or bromine in the presence of HCl. यदि bromine iron dark करिबा ताले कोन आइबो? That will give the ring substitution. जोटा में इलेक्ट्रोफिलिक आर्बिट्रेट substitution होचे. But एठी हम बेंजाइल ब्रोमाइड दरकार अछि माने साइड चेन रे substitution दरकार. So तापे हमको free radical substitution method ही follow करिबा को पड़ो. So this is the case. I hope all of you got this. बुझापड़ला. Note कर दियो. And now we are going to discuss the last one, the fifth question. Fifth question is, okay. This अब टर्मिनल पोजीशन रे फ्लोरीन दरकार अछि. हम डायरेक्ट फ्लोरीन तो नहीं परिबानी. एठी हमको सेम हाइड्रोजन पेरोक्साइड रो प्रेजेंस रे और एनी पेरोक्साइड रो प्रेजेंस रे हाइड्रोजन ब्रोमाइड न पड़िबो. So as a result of this, it gives 1 bromobutane, silver fluoride or any fluorinating agent. So bromine will be converted to fluorine. So this is the case. Quickly note कर दियो. यदि किसी का डाउट अच्छी, write down. Any doubt? Write in the chat box. Okay, anti-Markovnikov rule. Okay, समझिए. हम जल्दी जानते हैं स्टूडेंट. ठीक है, तो 50 मार्कोनिकोव एंटी-मार्कोनिकोव ठीक है मैं एक्सप्लेन कर दूंगी. Markovnikov rule. So Markovnikov rule is applicable for the addition in unsymmetrical unsaturated hydrocarbon. It is for unsymmetrical unsaturated hydrocarbon. So unsymmetrical unsaturated hydrocarbon, it may be your alkene or alkyne दुटा कहि परियो alkene भी परियो alkyne भी परियो जोटा unsymmetrical unsaturated hydrocarbon ठीक अच्छा ताले unsymmetrical unsaturated hydrocarbon रे हमें जदी ऐड करिवा सुन बुझि परछो unsymmetrical unsaturated hydrocarbon हमें एमिति गोटे मॉलिक्यूल ऐड करिवा जोटी बोथ cationic और anionic सेंटर थिबो बोथ पार्शियल पॉजिटिव और पार्शियल नेगेटिव चार्ज थिबो ताहले से केस रे कोन सपोज आम नौ H2 ऐड कर Cl2 ऐड कर एठी मार्कोनिकव रूल किछि भी सिग्निफिकेंस नाही जब हम HCl ऐड करिबा yes it has significance काहे कि HCl क्लोरीन रो पार्शियल नेगेटिव हाइड्रोजन रो पार्शियल पॉजिटिव तले कोन कहले ना व्हेन addition of unsymmetrical unsaturated hydrocarbon takes place then the negative part of the adenine goes to the carbon which contains lesser number of hydrogen तमाने सपोज हम जदी एठी ऐड करिबा HCl ऐड करिबा the negative part के chlorine कोडी जिवो ना to the carbon which contains lesser number of hydrogen this is the product I hope you got this is the product but the symmetrical alkene ache see this ame jodi HCl ऐड करछे there will be no difference in the product so the product will be 2 chloro butane without any other option एठी किछ ऑप्शन ही रहबनी बुझि परला मार्कोनिकव रूल नेगेटिव पार्ट ऑफ द adenine जे ऐड होबो जो adenine goes to the carbon which contains lesser number of hydrogen atoms this is the मार्कोनिकव रूल तले एंटी मार्कोनिकव रूल कोन हां आज देखिए हम मार्कोनिकव रूल रे द इंटरमीडिएट इज carbocation intermediate in Markovnikov rule the intermediate is carbocation intermediate ठीक तो एंटी मार्कोनिकव रूल देखिबा एंटी मार्कोनिकव रूल रे एंटी मार्कोनिकव रूल और खरास इफेक्ट एंटी मार्कोनिकव रूल और खरास इफेक्ट ओके अच्छा ताले एठी हम कोन देखिबा एंटी मार्कोनिकव रूल और खरास इफेक्ट कोन देखिबा ना ए देखिबा ना it is applicable for the addition of hydrogen bromide in the presence of peroxide peroxide मान जोटी ऑक्सीजन लिंकेज थाए H2O2 और R2O2 हम नहीं करियो एक केस रे कोन हुए the mechanism is or the reaction intermediate formed is free radical free radical intermediate बनछि जोटा कि कार्बोकेटन इंटरमीडिएट बनथिला कोथरे मार्कोनिकव रूल रे ठीक सो एठी कोन ना जतला हाइड्रोजन ब्रोमाइड को हम ऐड करबा इन अनसिमेट्रिकल अनसैचुरेटेड alkene एठी alkyne unsymmetrical unsaturated alkene in the presence of peroxide suppose CH3 followed by O2 लेकेस रे कोन हबो तो नेगेटिव पार्ट द ब्रोमीन अछि that goes to the carbon which contains more number of hydrogen means just opposite to the Markovnikov ये केवल मन रखो केवल applicable कहा पे ना addition of hydrogen bromide in the presence of peroxide hydrogen bromide भी थिबा दरकार आ peroxide थिबा दरकार ताहले एक कप में अप्लाई करबे बुझे परले स्टूडेंट जे पचारतलो समय जे इज इट क्लियर नाउ सपोज हमें एठी नउचे this hydrogen bromide H2O2 this is the product okay so the any other doubt NBS okay NBS is N bromosuccinamide NBS ना स्टूडेंट के पचास सुन दे NBS कहि दो छे N bromosuccinamide this is the structure of NBS so it is mild brominating agent. तो भूल जाए जस्ट लिख दियो mild brominating agent. तालार काम कौन ना it makes substitution of bromine at the allylic or benzylic position. It is mild brominating agent जे कि ब्रोमिनेशन करिवो दीटा पोजीशन रे allylic position और benzylic position. जेमते हम कहले so एठी this is benzylic position. So allylic position कौन a double bond on next position. This position is allylic position. So NBS only these two positions रे bromination करिवो other position रे bromination करि परिवो. Okay, other position रे bromination करि परिवो. Any other doubt? जहाँ the doubt अछि you can ask now. The doubt is कोई chat box से note करि परिवो. Okay, so this is as in the school NBS clear. The question बचा चलो. Okay, now we are going to discuss. We have already discussed SN reaction. तादरे SN1 reaction हमें last class से discuss करी थिले. ताको में एवं थोड़े revise करियो जाउचे. Then we'll discuss some questions from SN1 reaction. So SN1 reaction, it is the nucleophilic substitution unimolecular reaction. Again repeating, the SN1 reaction is a nucleophilic substitution unimolecular reaction. That means order of reaction is 1. Okay. So this reaction goes through 3 steps. One is the formation of carbocation. Just try to recall that last class discussed. One is the formation of carbocation. So this formation of carbocation is slow step and hence rate determining step. This formation of carbocation is slow step and hence rate determining step. Second, जो भी reaction में carbocation intermediate बनिवो, it may undergo rearrangement to form more stable carbocation. So that is the second step. Carbocation rearrangement may be possible. Then what is the third step? The third step is the to the stable carbocation center, attack of nucleophile takes place. To the stable carbocation center, attack of nucleophile takes place. Okay. So these are the 3 steps. So this is the SN1 reaction. ताले it factors affecting SN1 reaction. Who factor affect करूँ? First nature of the haloalkane. I mean, this reaction goes through the formation of carbocation intermediate. More the stability of carbocation, again repeating, more the stability of carbocation, more easily it can be formed, and hence more is the reactivity of haloalkane. More is the reactivity of haloalkane. Okay? अच्छा. ताले it is more stable, माने stability of carbocation depend करছে. First. Second is the nature of the solvent. This reaction takes place in the presence of polar protic solvent. The polar protic solvent helps in dissociating the bond between carbon and halogen. The carbon and halogen with the bond that will be dissociated by the help of polar protic solvent. Okay? So this is the second one. So third the third is third point. The third point is the nature of the living group. Better living group that easily depart, easily dissociate. Better the living group, more is the chances of SN1 reaction. ओके नेक्स्ट SN1 खाली ना SN2 जो भी रिएक्शन न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन होची यदि न्यूक्लियोफाइल स्ट्रॉन्गर थिबो आउ लिविंग ग्रुप वीकर थिबो सॉरी लिविंग ग्रुप बेटर लिविंग ग्रुप थिबो ओके न्यूक्लियोफाइल न्यूक्लियोफिलिसिटी अधिक थिबो आ लिविंग ग्रुप रो लिविंग ग्रुप एप्टीट्यूड अधिक थिबो ताले से केस रे द सब्स्टिट्यूशन रिएक्शन मे टेक प्लेस इजी the substitution reaction may take place easily. Okay, pretty clear? अच्छा ताले next कौन थिला ना एठी हम कहि परिबा concentration of the nucleophile there will be no effect of concentration of the nucleophile because the nucleophile concentration काहे के अफेक्ट करबनी को nucleophile concentration काहे के अफेक्ट करबनी ना in the slow step or redeterminate step nucleophile is not there ठीक नेक्स्ट है स्टीरियोकेमिस्ट्री तो स्टीरियोकेमिस्ट्री के कौन होगा स्टीरियोकेमिस्ट्री तुम कहते इट कैन बी इन जनरल स्टीरियोकेमिस्ट्री कहले जो पोजीशन रे तमरो लिविंग ग्रुप थिला सो न्यूक्लियोफाइल एग्जैक्टली सही पोजीशन रे अटैच होई पारे न्यूक्लियोफाइल एग्जैक्टली सही पोजीशन अटैच होई पारे और डिफरेंट पोजीशन अटैच डिफरेंट पोजीशन माने कोन ना अपोजिट टू द लिविंग ग्रुप ऑपोजिट है एटा जिवो इन्वर्जन कॉन्फ़िगरेशन देन लिविंग ग्रुप रो सेम पोजीशन में हो रिटेंशन कॉन्फ़िगरेशन और बोथ है दैट इज नोन एज द रेसिमाइजेशन ऑफ कॉन्फ़िगरेशन सो एटी कार्बोहाइड्रेट बनेला पर न्यूक्लियोफाइल अटैक करथिला यदि कार्बोहाइड्रेट बनेला पर न्यूक्लियोफाइल अटैक करथिला so this reaction goes through racemization of configuration this reaction goes through racemization of configuration बुझि परलो अच्छा ताले हमें एटा देखिले कोन now what is the role of the nucleophile sorry what is the stereochemistry तापर देखिबा किछि क्वेश्चन एसएन रिएक्शन रो क्वेश्चन मो लेखुची तो सॉल्व करा which alkyl halide exhibits which alkyl halide exhibits complete of racemization in SN1 reaction. So write down the questions. Second question. Which of the following compound is inactive towards SN1 reaction? Then C. Okay. Later question student फटाफट लिखो. Take 2-3 minutes. तापर में question discussion करें. Make it fast. I hope all of you tried. Now we are going to discuss. Can try with the student? Can you write your answer? Write down your answer. In the chat box. C. Okay. DCC Tangi, C means which one you are saying? First question or second question? So first or second? First one. Okay, we'll see. A second question. So answer, I mean, by way, answer to first answer is D, second is C. Now we are going to discuss it. We are going to discuss it. Now, I'm going to first one. Which alkyl halide exhibit complete racemization in SN1 reaction? Complete racemization in SN1 reaction, right? If the complete racemization is pachariba, tale iti kon habo ko na racemization goes through racemization code huye. Racemization huye SN1 reaction. Tamane abhi jete reaction dechi kodi SN1 reaction hobar chances adhik achi. Kodi SN1 reaction hobar chances adhik achi na jodi carbocation stability adhik achi. Kodi carbocation stability adhik hobo na carbocation stability adhik hobo option D re. Carbocation stability adhik hobo option D re. Okay? Okay. So this is the answer. So carbocation stability is more in option D. Next, kahinki na benzyl carbocation. So that goes through complete racemization in SN1 reaction. Second, inactive towards SN1 reaction. तामाने अभी तो कोटा SN1 reaction दबनी. Okay. अभी तो कोटा SN1 reaction दबनी. SN1 reaction कोटा दबनी को ना जोटी कार्बोकेटन easily बनी जोटी कार्बोकेटन easily बनी. इधर देखिए ऑप्शन सी रे ये जो पोजीशन अछि. This position is known as bridgehead position. This position is known as bridgehead position. यदि bridgehead position है ला, ताले केस रे bridgehead position रे ना elimination हुए ना substitution हुए. इधर नोट कर दियो. At the bridgehead position माने जोटी तीनटा कार्बन ओटे रिंग रे meet कर सकते. That is bridgehead position. So right at the bridgehead position, neither the substitution nor the elimination, reaction can take place. Reaction can take place. Okay. मुझे बोलना. So I think it is clear. At the bridgehead position, neither the elimination nor the substitution reaction can take place. तामाने जो option C अछि, so that cannot undergo the elimination or substitution easily. So that is least or inactive towards SN1 reaction. Allow data question लिख लो. arrange the reactivity towards SN1 reaction. Arrange the reactivity towards SN1 reaction. Write down the questions towards SN1 reaction. Towards SN1 reaction. Write down the questions. Question completed. This is the reactivity towards SN1 reaction. SN1 reaction रो reactivity लिखो ये तीनटा question. Take 2-3 minutes. Chapter में फिर start करेगा SN2 reaction. Print quick. Last 2 minutes. Simple कथा है देखिए पड़िबो the react or stability of the carbon atom. Okay, आपके देखिए अच्छी stability of the carbon atom. Quick students. Then all of you doing. Okay. Now I'm going to write the answer first. First question, answer alert. 1, then 4, then 5, 4, 5, 3, then 2. Okay. This next is 3, 2, 1, 4. Last one is 3, 1, 4, 2. Compare with the answer. Quick. Compare with the answer. Discuss. Simply, the it is only the stability of the carbon atom. Only the stability of the carbon atom. अच्छा, कल देखिए आदि, but it's a confusion of student. Question number 1 between the stability of benzyl and tertiary butyl. Okay, so benzyl and tertiary butyl ଭିତରେ ଯଦି ଆମେ ଦେଖିବା solution phase rate, benzyl is more stable than tertiary butyl. यदि gas phase रे देखिवा tertiary butyl is more stable than benzyl. Okay, in gaseous phase tertiary butyl is more stable than benzyl. और there is solution देखिए benzyl is more stable than tertiary butyl. So I hope no need to explain. ताले एठी जो reaction होचे SN1 माने that is in the polar protein solvent. तो सेटा केबे भी gaseous phase रे होबनी, solution phase रे होबो. Solution phase रे tertiary butyl to benzyl more stable. So first एगला benzyl, then tertiary butyl, then your allyl. तापर second रे जानचे chlorobenzene is least reactive. काहेंगे chlorobenzene least reactive? Because it has partial double bond character. Carbon chlorine has partial double bond character. Second case रे जेमते टिके पूरा डिस्कस करते हैं, क्वेश्चन that is related to stability of carbon atom. So it will be same. So it is plus R, NO2 minus R, it is plus R. So plus R effect NH2 रो OH ଠାରୁ ଅଧିକ ଅଛି. So that is the answer. तापर जे देखिबा एठी देखो it is also plus R effect. आ एठी fourth one जे देखिबा एठी कोन ना कार्बोकेटायन बनिबो but that is not stabilized by resonance जोटा कि माने first आउ third case रे कार्बोकेटायन will be stabilized by resonance. Okay, first and third case रे कार्बोकेटायन is stabilized by resonance, but in the second case the carbocation cannot be stabilized by resonance. Okay, clear? So this is the answer. Now we are going to start SN2 reaction. SN2 reaction. So what is this SN2 reaction? Now nucleophilic substitution bimolecular reaction. Nucleophilic substitution bimolecular reaction. That means order of the reaction equal to 2. So how to write this? You can write the rate of the reaction is proportional to the haloalkane and nucleophile, or R equal to K haloalkane and nucleophile. Okay, so since this is the rate expression or rate law, so order kon hejibo na order of reaction is 2. Order of the reaction is 2. Okay, I think it is clear to all of you. It is clear. Ela tomorrow SN2 reaction. So mechanism. So if you see mechanism, it follows concerted mechanism. So what is the meaning of concerted mechanism? The concerted mechanism is that in which bond formation and dissociation takes place simultaneously. Concerted mechanism is that in which bond formation and dissociation both are taking place simultaneously. Okay, so it is the concerted mechanism meaning. It हम कौन देखिबा ना haloalkane अछि. So let's say haloalkane and nucleophile is supposed to attack from the opposite side of the leaving group. Nucleophile supposed to attack from the opposite side of the leaving group. Then nucleophile starts making bond with the carbon, and simultaneously the bond between carbon and halogen is starts dissociating. So the intermediate form, it is known as transition state or activated complex. So transition state माने कौन? Now from this state, it may lead to the product formation or it may reverse back to the reactor. And the intermediate vanilla, intermediate देखो nucleophile भी अच्छी और halogen अच्छी. Nucleophile halogen means nucleophile leaving group both are present simultaneously. So then the nucleophile और carbon भितर bond जेतोल dissociate होगा start होची simultaneously leaving group और carbon भितर bond reverse करी nucleophile और carbon भितर bond formation होगा start होची simultaneously carbon and leaving group भितर bond dissociate होगा start. So both are taking place simultaneously. If these are simultaneously hochi, then we can name it as concerted mechanism. We can name it as concerted mechanism. Next कौन होगा? Next होगा the bond between the nucleophile and carbon formed and the leaving group is released and the leaving group is released. Okay, so এটি আমরা দেখিলে কোন now why the name is concentrated mechanism, because both the bond formation and dissociation are taking place simultaneously. स्टूडेंट आपको टिके नोट कर दियो, क्विकली नोट डाउन. बाकी यहाँ पर आज में डिस्कस करियो SN टू द आर फैक्टर्स को डिस्कस करियो, then we'll discuss the next one, that is your SNI and NGP. SN and NGP আমার board syllabus এ नहीं but competitive exam রে আছে. Quickly note करो फ्रेंड. एपर्यंत किसी कार के डाउट अछि, राइट इन द चैट बॉक्स. Any doubts, friend? Okay, hello friend. I hope SN2 just আমাকে start করলে সেটা বুঝা পড়তিব. Now take break. After the break, we'll then continue SN2. তারপর যেতে গেলে SNI और NGP তারপর ডিসকাস করিও after the break. Okay, so stay logged in. लॉग आउट करे दरकार नहीं, हमें ब्रेक पर आज कंटिन्यू करेगा.